Hello, and welcome to an incredible journey through time and space. We're going to be exploring the epic story of our universe from its very beginning to the dawn of civilization. Get ready to be amazed as we travel billions of years back in time. Our destination, the very birth of everything we know and love. This is a story of cosmic fire and ice, of unimaginable forces shaping the universe as we know it. We'll witness the birth of stars, the creation of planets, and the very conditions that made life possible on our own planet Earth. Fasten your seatbelts and prepare to be amazed. The universe is waiting to be discovered. Let's begin our journey. Imagine, if you will, a time when there was no time, no space, no matter. It's hard to even fathom, isn't it? But then, about 13.8 billion years ago, something incredible happened. Scientists call it the Big Bang. In an instant, everything exploded outwards from an infinitesimally small point. It was an explosion of unimaginable power and heat. Space itself expanded rapidly, carrying with it a sea of energy and particles. As the universe expanded, it began to cool. Energy transformed into matter, forming the building blocks of everything we see around us today. The Big Bang wasn't an explosion space, it was the explosion space itself. It's a concept so vast, it's hard to wrap our heads around. As the universe continued to evolve, gravity began to work its magic. Giant clouds of hydrogen and helium gas, remnants of the Big Bang, started to clump together. These clumps grew larger and denser over millions of years. Eventually, the pressure within these massive clouds became so intense that nuclear fusion ignited. Stars were born, shining brightly across the vast expanse of space. Our own galaxy, the Milky Way, formed amidst this cosmic dance. It's a swirling disk of billions of stars, gas and dust. The Milky Way is so vast that it takes light over 100,000 years to travel from one side to the other. Within this grand spiral, our own solar system was about to form. A tiny speck in the vast cosmic tapestry, yet destined to be our home. About 4.6 billion years ago, in a quiet corner of the Milky Way, a giant cloud of gas and dust began to collapse under its own gravity. This cloud, known as a solar nebula, was composed of remnants from previous generations of stars. Over time, the gravitational forces within the nebula caused it to contract and heat up, setting the stage for a dramatic transformation. This event, triggered perhaps by the shockwave of a nearby supernova, set the stage for the birth of our Sun. The shockwave would have compressed parts of the nebula, causing regions of higher density that would eventually become the core of our solar system. As the cloud contracted, it began to spin faster and faster, like a spinning figure skater pulling their arms in. This increase in rotation caused the cloud to flatten into a disc shape, with most of the material being pulled toward the center. The core of the cloud became incredibly dense and hot, reaching temperatures of millions of degrees. This central region, known as the protostar, continued to gather mass and heat, becoming the hottest and densest part of the forming solar system. Finally, the pressure and temperature became so intense that nuclear fusion began. This process, where hydrogen atoms combine to form helium, releases a tremendous amount of energy. Hydrogen atoms fuse together, releasing enormous amounts of energy. This energy radiated outward, counteracting the force of gravity and stabilizing the young star. Our Sun, a giant ball of burning hydrogen, burst to life. This marked the beginning of a new era in the cosmos, as the Sun's light and heat began to influence the surrounding space. This event, the birth of our Sun, was the single most important event in the history of our planet. It provided the necessary conditions for the formation of the Earth and the other planets in our solar system. Without the Sun's energy, life on Earth would not be possible. The Sun's light and warmth drive the processes that sustain life, from photosynthesis in plants to the climate and weather patterns that shape our environment. The Sun truly is the heart of our solar system, and its birth was a pivotal moment in the history of the universe. Section 5. Earth's fiery birth. A planet takes shape. The birth of our sun wasn't a solitary event. It was a dramatic and violent process, a cosmic dance of gas and dust collapsing under gravity, igniting nuclear fusion and giving birth to a new star. This event marked the beginning of our solar system. Surrounding the newborn star was a swirling disk of leftover gas and dust, remnants of the original cloud that had collapsed. This protoplanetary disk was a chaotic environment, filled with turbulent eddies and currents, where particles constantly collided and merged. Within this disk, tiny particles of dust and ice began to collide and stick together. These collisions were not random. They were governed by the laws of physics, gradually leading to the formation of larger and more complex structures. Over millions of years, these collisions created larger and larger bodies called planetesimals. These planetesimals were the building blocks of planets, each collision adding mass and complexity to these growing celestial bodies. These planetesimals, drawn together by gravity, continued to collide and grow, eventually forming the planets we know today. The process was slow and often violent, with massive impacts shaping the young worlds. Earth, our home, was one of these young, fiery planets, still bombarded by asteroids and comets. These impacts played a crucial role in shaping the planet's surface and atmosphere, contributing essential elements and compounds. It was a time of intense heat and chaos, a far cry from the peaceful planet we know today. The surface was molten, and volcanic activity was rampant, creating a hellish landscape that seemed inhospitable to life. But within this fiery crucible, the stage was being set for the emergence of life itself. The conditions, though harsh, were perfect for the complex chemical reactions that would eventually lead to the first living organisms. This was the dawn of a new era, the beginning of the story of life on Earth. Section 6, Lunar Lullaby, the Moon's dramatic arrival. While the Earth was still in its infancy, a dramatic event occurred that would forever shape our planet. A Mars-sized object, which scientists call Theia, collided with the young Earth. The impact was cataclysmic, vaporizing vast amounts of rock and debris. Some of this material was ejected into space, where it eventually coalesced under its own gravity to form our Moon. The Moon's gravitational pull stabilized Earth's rotation, preventing wild swings in our climate. The tides, caused by the Moon's gravity, played a crucial role in shaping coastlines and influencing the evolution of life. This celestial dance between Earth and Moon, a consequence of a cataclysmic event, created the conditions necessary for life to flourish. Section 7. Oceans of time water flows on Earth. As Earth cooled down after the Moon-forming impact, its surface solidified, forming the first continents. Volcanoes erupted, spewing gases and water vapor into the atmosphere. Over millions of years, this water vapor condensed and fell as rain, filling the low-lying areas and forming the first oceans. These early oceans were likely acidic and hot, but they set the stage for the emergence of life. Water is essential for life as we know it. It acts as a solvent, allowing chemical reactions to occur. The early oceans provided the perfect environment for the building blocks of life to interact and evolve. From the fiery chaos of Earth's formation, a new era was dawning, an era shaped by the presence of liquid water. Section 8. The breath of life from chemistry to biology. The early Earth was a world teeming with chemical activity. Volcanic eruptions released gases into the atmosphere, lightning storms raged across the skies, and meteorites bombarded the planet's surface. Within this dynamic environment, complex organic molecules, the building blocks of life, began to form. Scientists believe that these molecules may have formed in shallow pools of water, or perhaps near hydrothermal vents on the ocean floor. Over millions of years, these organic molecules assembled into more complex structures, eventually giving rise to the first self-replicating molecules, the precursors to DNA and RNA. The exact details of how life arose from non-living matter remain a mystery, but we do know that the early Earth provided the perfect conditions for this remarkable event to occur. Section 9, Conclusion, a journey through time. Our journey through prehistory has taken us from the Big Bang, the moment when the universe burst into existence, to the very brink of life, where the first microscopic organisms began to emerge in the primordial soup of early Earth. We've witnessed the birth of stars, the formation of planets, and the swirling nebulae that paint the cosmos with their ethereal beauty. We've seen the incredible chain of events that made our own planet habitable, from volcanic activity to the formation of oceans and continents. The story of prehistory is a testament to the immense scale of time and space, a narrative that stretches across billions of years and countless galaxies. It's a story that fills us with awe and wonder as we gaze up at the night sky and ponder our place in the universe. It reminds us that we are part of something much greater than ourselves, a vast and interconnected web of life and matter. As we delve deeper into the history of life on Earth, we uncover the incredible journey of evolution, from simple organisms to complex beings. Remember the incredible journey that brought us here, a journey marked by adaptation, survival, and the relentless march of time. From the heart of a dying star, where elements are forged in the crucible of a supernova, to the depths of the primordial oceans, where life may have first sparked in the warmth of hydrothermal vents, our origins are inextricably linked to the cosmos, a reminder of our cosmic heritage and the wonders of the universe. Thank you for joining me on this incredible adventure through time and space. Together we've explored the vastness of the universe and the intricate details